Hi, I'm Cary Millsap. Today I'm going to tell you a story about how you can use my company's Method R Workbench to diagnose a pesky intermittent performance problem. The story begins with a customer whose application would time out whenever their database took longer than 5 seconds to respond to a request. It would happen only about once every 10,000 transactions, but their transaction rate was so high they were getting 10 timeouts per hour. Unfortunately, each timeout created a big problem for the business. They hadn't been able to diagnose their problem because the diagnostic data for every bad transaction was buried by the diagnostic data for 10,000 good transactions. We needed to catch the application in the act of misbehaving, so I asked the customer to enable tracing for the whole database for about an hour. We figured that'd be long enough to catch a few timeouts, and it was. The trace produced almost 5 million lines of data in 67 files. The customer told us that during the trace, they had executed about 90,000 transactions and there had been some timeouts. One transaction had taken 9.5 seconds to run. That's exactly the kind of thing we'd been hoping to catch. I've disguised this customer's trace file so I can show you how to use Method R Workbench to find that 9.5 second transaction and then explain why it took 9.5 seconds. It's not going to take long. Here's what the Method R Workbench looks like. I can load all 67 files into it by dragging the whole directory from my Finder. The load takes only a few seconds, and I don't even have to wait for it to finish. I can get going right away. The Workbench ships with more than 30 pre-configured reports. The one I'll use today is called Duration by Island ID. This report uses a little Method R magic to aggregate trace lines from a connection-pooled application into individual user experiences. It's literally a report about durations that people have experienced when they use the application. So I'll make sure that all 67 files are selected and I'll run the report. I happen to know that for this set of files, the right think time threshold value to use is 10 milliseconds. My book shows how to find the right value. The report doesn't take very long to run. And there we go. The Workbench has found the 9.5 second transaction the customer told me about. This is the file it's in, and here's the line number where the transaction begins. The Workbench has found about 90,000 distinct transactions, just like my customer described. Now, it may not seem like it because it took so little effort to get here, but the report you see here is astonishing. It is a list of durations that people actually felt as they used the application. Chances are you've never seen a report like this before. And even if you have, well, you haven't seen anything like what I'm going to do next. One of the best things about Oracle Trace data is the detail. Behind every duration in this report is a list of every single database call and system call that contributed to that duration. But there's a problem. The data for this transaction that I'm interested in is buried in a file containing almost 5,000 other transactions that I don't care about right now. What I want is a trace file that contains nothing but the 9.4 seconds I'm interested in all by itself. Well, happily, doing that is just one command in the Workbench. The command is called Mr. Crop. It lets you crop a trace file just like you'd crop a photograph. I'll supply the island subcommand, the think time threshold, the island ID, and the file name. And now I have a 549 line trace file containing just my 9.4 second experience. I can load it into the Workbench, and with one click, I have a full-color, shareable HTML5 report that explains why that transaction took 9.4 seconds. Here, you can see that the transaction spent 85% of its user's time waiting on a lock, and here's the SQL statement that was waiting for it. Fixing this one is going to require a little work on the application code. Let's recap what you've just seen. We had an intermittent performance problem, so we traced the whole system for long enough to catch a few of these problems in the act. That trace created 67 trace files, almost 5 million lines of trace data. But in less than a minute, I found the 549 lines that I cared about. And now I know exactly where I need to apply effort to make the application better. With Method R Workbench, I can filter through huge volumes of richly detailed data to see performance the way the business wants to see it. And I can do it fast. The story I've told today is about solving a performance problem, but people use our Workbench for lots more than just troubleshooting. Method R Workbench is high-precision time measurement software that helps you in every phase of the software development lifecycle. I'm Cary Millsap. Thank you for watching.